Today we are starting a new chapter, that is chapter number 14, Chemical Effects of Electric Current. If you remember, last year we have discussed two different effects of electric current. Yes, right. We have discussed the uh, heating effect of electric current and the magnetic effect of electric current. This year we will be discussing about chemical effect of electric current. So what does this imply, or what do we mean by chemical effects of electric current? When we are allowing the current to pass through any liquid, if the liquid is able to conduct the electricity and at the same time it is undergoing chemical change, this effect of electric current is known as chemical effect of electric current. Right? That means if I have used any X solution and in this I have inserted the bare ends of the wire which are connected to the battery, and at the same time it is connected to the bulb. If this bulb is glowing, this indicates that current is passing. This liquid is allowing the current to pass through it. Second thing, that is the bulb is glowing, that is also indicating that this liquid is helping in conducting the electricity. Now if you see or if you observe this beaker, you will find some bubbles are coming out. Naturally, there is some change occurring in the liquid also. About this change and what are the products produced, that we will study in due course of time. For the time being, understand what is chemical effect of currents. Under this heading of chemical effect of electric current, we will try to understand why the certain liquid is able to conduct electricity and why not some of the liquids they conduct electricity, or current is not passing through them, or what are the products formed when the current is passing through the liquid. All these things will be discussing in this chapter. Not only this, where do we use this effect of electric current, that also we will be discussing in this chapter. Before we move over to different activities, we need to understand some basic keywords such as conductors, insulators, and different materials which can be used as tester, etc. So we all know that what are good conductors of electricity. Yes, the material which will allow the current to pass through it is considered as good conductor of electricity, and the one which will not allow the current to pass through it is called as insulator. But in this chapter we will be discussing about good conductor as well as poor conductor. Good conductor of electricity and poor conductor of electricity. Okay, now based on this, the liquid which is helping the current to pass through it is considered as good conductor of electricity. The other name for this good conductor of electricity is electrolyte. Electrolyte. It is the liquid or it is the solution which allows the current to pass through it, at the same time undergoes chemical change, is known as electrolyte. Generally, the examples of these electrolytes are all aqueous solutions. It can be salt solution, it can be acidic solution, or it can be a basic solution, but it is aqueous solution. Okay, now you have to understand what do we mean by aqueous solution. We all know that there are two components in a solution. One is solute, the other one is solvent. If we are using water as a solvent, all such liquids are called as aqueous solutions. They are known as aqueous solutions. So you may ask, uh, generally all the solutions are prepared by using water only. It is not true. We can dissolve solute in different solvents other than water also, like organic solvents or alcohol, ether, benzene, etc. All such solutions where other than water is used are called as non-aqueous solution. Non-aqueous solution. So, the one which will allow the current to pass through it and it will undergo the chemical change is known as electrolyte. And generally the examples of electrolytes are all aqueous solution, or in a melted condition also few of the substances they conduct electricity. Now coming to the poor conductor of electricity, they are known as non-electrolytes. They are known as non-electrolytes. These are the keywords which you need to understand, keep in mind. 174 and 175, all these keywords are given. Okay, one by one we will try to understand the meaning of these keywords. Then we will conduct the activities so that you will understand the topic very well. Clear? So, first thing is chemical effect of current. Second thing, electrolytes and non-electrolytes. Example of non-electrolytes is oils, different oils, they do not conduct electricity. Alcohol, it does not conduct electricity. Okay, or it does not, it is not that only the solutions which are made out of different organic solvents are non-electrolytes. There are some of the substances, even if you dissolve them in water, they do not conduct electricity, such as sugar solution. Sugar solution will not conduct electricity. So that can also be called as non-electrolyte. Now we have understood the difference between electrolyte and non-electrolyte. Now, if we have to test any solution or find out whether it is a given solution is an electrolyte or a non-electrolyte, we need some material like the wires, insulated wires, then battery or cells, and then bulb and two electrodes, and if required one switch. But if we use bulb, it is not necessary that always the electrolyte will light the bulb. If this liquid is a weak conductor of electricity, this bulb may not glow. So for such purposes, we can use LED or the magnetic compass. LED, you all are familiar with LEDs. Just now we have celebrated Diwali and we have illuminated our house using the electric series in which these LED bulbs are used. This LED has the ability to detect weak current also. If you see the structure of this LED, it's like a small bulb having one terminal, two wires connected to it. One is longer, the other one is shorter. These two are called as leads. The longer one is always connected to the positive terminal of the battery, and the shorter one is always connected to the negative terminal of the battery. Now when this LED is used, even if it is a weak solution like lemon water, or it is the lime water, etc., then also it will be able to detect the current flow and the bulb will glow. And last year also we have studied about the Oersted apparatus, in which we have found that when the compass is placed near the copper wire which is carrying the current, the needle of the compass deflects. It shows the deflection. That indicates that the current carrying wire creates a magnetic field around it, due to which the magnetic needle gets deflected. So we will be performing few of the activities in our next class, so that you will observe how this LED bulb works, or how we can classify different solutions present in our day-to-day life, or the one which we use in our day-to-day life, into two groups, electrolytes and non-electrolytes. Till then, you read page number 174 and 175, so that your concepts related to the keywords which we will be using in this chapter will be clear. In case of doubt, you can ask me in our next online class. Till then, take care. Bye.